Hi and welcome to another video from TOGAtech. My name's Dave. In today's video we'll be building this, which is the Autopilot and EFIS panel for a Airbus A320. Just before we start our build, this is actually part 3 of a series of videos. If you want to see the rest of them, there's a link to them in the description below. In parts 1 and 2 we were building a generic autopilot panel using a LeoBodner input-output card. In part 3 we'll be building the A320 Airbus style autopilot, and we'll be using a Arduino Mega to control this, so that we can have both the inputs from the switches and the rotary encoders and the outputs of the LEDs. I found that as Microsoft Flight Sim was progressing, we were getting more and more functions working on the A320, and it is far more my aircraft of choice over the smaller aircraft. I do prefer the airliners, and so now I decided to switch from the generic autopilot to a dedicated A320 one. Well, let's get on with the build, and I'll talk you through using the Arduino Mega, which is a 256 Mega, and we'll be using Mobiflight to do all the inputs. All links to all the files, downloads and the wiring diagrams are all in the description below. Let's get on with the build. Okay, in this part 3 of this video series we're going to be concentrating on the dedicated Airbus A320 FCU panel. Now, if you've been following this series, in the last 2 videos we were building the General Aviation MCP, but the principles in this are exactly the same. In the previous 2 videos we did the buttons and the rotary encoders connected to a LeoBodner card, which only has inputs. There are no outputs on a LeoBodner card. So for this dedicated FCU, the Airbus A320 FCU, we'll be using an Arduino Mega to be specific, so that we can have inputs and outputs. So on this is the FCU panel. We're going to have inputs are going to be our buttons and our rotary encoders, and our outputs are going to be the LED indicator lights, which go along with these functions here. So for the LEDs, what you're going to need to make up is a number of these. You need your LED. Now, depending on what position it is on the FCU as to what colour you use, I'm using greens and reds. Even though this is a clear LED, it's actually green. So you need one of those. You need a 220 ohm resistor and a couple of cables. These are DuPont cables like that, but you can use any bit of cabling you want. Now the reason for the resistor is these LEDs roughly run at 3.3 volts and the output from your Arduino card is 5 volts. So we need a way of reducing the voltage going through this LED. Otherwise the 5 volts will soon burn out the LED. So what we're using is that resistor, and that will reduce the voltage from 5 volts to 3.3 volts. And then all you've got to do is solder these up. Doesn't matter which leg you put it on, either the anode or the cathode. Solder that resistor to one leg of the LED, and then solder one of these cables to the other end of that resistor, and then the other cable will go to the other leg of the LED, like that. And you'll end up with something like this. Here you are, my 2 cables. There's my LED. I've shrink wrapped them. Underneath this bit of red shrink wrapping is the 220 ohm resistor. Now you need to make up a number of these. If you're doing the general aviation MCP, you're going to need 15. If you're doing the dedicated Airbus FCU, you're going to need far less. 1, 2, 3, 4, 5, 6, and then on the EFIS panel, which is this one, 2 on there, 7, 8. So you're going to need 8 LEDs in total. Once you've made up your number of LEDs here, all you're going to do is, these have got 5mm holes in them next to the switches. I'm going to insert the LED into the back of the panel where the light has to go and hot glue them in. Now I'm not going to bore you with that, so I'm going to do that off camera and I'll come back to you when that's done. Right, I've now glued in all the LEDs on the back here, just using a bit of hot glue. I'll flip that over, you can just see them there. So I've got my green LEDs here for Autopilot 1, Autopilot 2. I've got my localizer, I've got my expedite, and I've got my approach. The only thing I used a red LED for is the auto throttle there. So that's all the LEDs in. We've already got our push buttons in, which you've seen in the previous videos, how to fit those, and our rotary encoders as well, already installed. The only other thing I'm going to put on this at the moment, you can see there's 2 holes for 2 displays. Now, at the present, I'm only going to be able to get one function in, I believe. This here is a 16 by 2 LCD screen. It's got 16 characters on it, 16 characters long by 2 lines deep. Now we're going to be able to display a certain number of items on here, probably the altitude and the heading. You can combine these, you can daisy chain these to have the 2 displays working, but that will be in a future video because I'm not quite sure how we go about doing that. There's something about changing the address of these LCDs with these little tabs on the back here, so that the Arduino knows that it's the second LCD in the chain and not the first, so it doesn't overwrite the others. But that's a completely separate video. This LCD also has what's known as an I2C unit on the back, and what this gives us, the advantage of this is, instead of having to have 16 connections along the bottom there going to our Arduino, which then means we'll lose 16 inputs on our Arduino, it reduces it down to just these 4, which is actually, it's a 2 input or an input output tab. So you've got 2 there, which is a DT, an SCL, and then you've got your ground and you've got your positive 5 volts. So it reduces those 16 connections down to just 4, which is a great advantage. Saves your input outputs on your card. Now I'm going to solder this unit in. All we need to connect this up with is 4 DuPont cables. So I'm going to get 4 cables out the bag here. Let's see what we've got. So we need a female on one end and a male on the other, or whatever. It doesn't matter because I'm actually going to be cutting the end of these cables. So let's see, if we go with our data cables, we're going to keep yellow and orange, and we'll keep our 5 volts red and our ground in brown on this case. So if I peel those off, there's our 4 connections. So we're going to go, it's got it written on here, SCL, and our other data cable, which is SDA, which goes, I'll put the orange on the SDA, VCC, which is actually our 5 volts, which I'll use as red, our VCC. I'll leave a link to all the circuit diagrams, all the wiring diagrams, and to all the files, the STL files and the SVG files for cutting the panels in the description below. You'll be able to download them from my Dropbox. And this brown wire goes to ground. That's it. Now what we're going to do is try and glue this in the back of our unit. I'm going to do it over the first hole here, because these are our speed and our heading, and then we've got our altimeter and that over this side. But I'm going to use the first hole to slot that into and glue that in position there. And then, as I say, once I've learnt how to link these up, I shall put a second unit in as well to display the other functions. Now, let's see if I can glue that in with a little bit of hot glue. I do put a couple of blobs of hot glue around this and then push it in place, just making sure you've got it the right way up. Now, I think it goes that way up, but it does look upside down on this right in here. I am not sure. I might do it the way that the writing is, so I'll do it that way up instead. We'll find out when we turn it on. Alright, let's put some glue in the corners. Don't do too much then, in case I've got to pull it out. Sit up a little bit, so put a little glue. And I'm just going to drop that in there. It's going to be a little bit raised, so keep that level. Go. Check how that looks on the front. Just make sure it's square. Glue's still hot. It's not quite right. That needs to push back. There we go. One LCD unit in. Like so. This is the Arduino Mega. It has 54 input outputs. The reason for this is each of these input outputs, they can be either designated as an output or designated as an input. That you do with the software. So as far as the board's concerned, it's just a connection point. When you use the software, you decide whether or not it's an input or an output. And we've got 54 of them on this board, so there's plenty, absolutely plenty. So for each LED, again, don't forget to download the wiring diagrams and connection diagrams. Might make it simpler. But here's one of our LEDs. So what we'd have to do with one of these, one end has to go to our 5 volts. Now, because you've got limited amount of 5 volt and ground connections on this board, what I'll do is I'll split this off to another board, like a version of a breadboard, so we can have multiple connections on the 1 5 volt. But if you just cut this, if we just go for one LED, I'll show you what you would do. You'd need one lead, that's the anode. Now don't forget, these are LEDs, light emitting diodes, and diodes will only pass current through in one direction. So you must make sure you've got these wired up the right way round, otherwise they won't come on. So the anode, which is your positive, will go to your 5 volts, and your cathode, which is your negative side of the LED, will go to whichever pin you designate to be the pin for this LED in the software. It'll all come a bit clearer a bit later on. But say we're going to say pin 1 is our auto throttle LED, so you'd plug that into pin 1. And then whenever you activate the auto throttle, this LED will come on. Now you can assign that to whatever one you want. The same again, you can just say, right, on pin 2, so we'll have another LED wired up to pin 2, and we'll designate pin 2 as being our Autopilot 1. So whenever you press AP1 on your FCU, this light will come on. And that's all we're going to do. As you say, if you check in the description below, download the list, you'll see a list of all the connection points for each LED and for their function, and then you can set it up exactly the same as I have it, or if not, you can do it whichever way you'd like to do, whichever pins you want to assign to whichever LEDs you're doing again. So now, because we've got 54 here, which is quite a lot, but we're going to need one for each button. Every button has got to have an individual input on this card. Every LED has to have an input, and every rotary encoder needs 3 inputs. Each rotary encoder needs 3 inputs. But have a look at the connection diagrams, download them from my Dropbox, and you can see exactly where I've put them all in, and it will make more sense. Now what I'm going to do now is I'm going to wire these up to the Arduino, and we'll take it from there, see how it goes from there. Okay, be back shortly. Just a little additional thing on here. Now, to make my wiring a little bit easier, I purchased one of these. Now this is optional, you don't have to have one of these, but this is called an Arduino Shield. I'll leave a link to where you can buy one of these in the description below. But what this does, this fits on top of your Arduino. With your Arduino, you see you've got these type of connections where you need to use your male DuPont cables to connect, and they just push in there. It's nice and simple, like that. Now this is going to get very complicated when you've got so many connections going in along here where they're going to be doubled up. Plus I'm using, on my rotary encoders and switches, I'm using single core cable which haven't got the pins that fit into the Arduino. So what I've purchased is this, which is called an Arduino Shield. This sits on top of your Arduino, just sits on top of the Arduino like that, and it's got pins on the bottom. These pins locate to the pin connectors on your board. Once they're lined up, just push them together. Do it gently, make sure all the pins are lined up. Sometimes the pins can go out of line a bit. Just pushing that on. There you go. So that's located with on top of my Arduino now. And what this does, on here, on the edge here, you can see these are all screw terminals. And these screw terminals are internally wired to those connectors on the Arduino. Just makes it simpler if you're using single core cable or multi-stranded cable. You can use these to connect it in. All you've got to do is undo the little screw at the top, put your wire in and screw it down. It's just a standard screw terminal. But the way it spreads it out, like here where you've got two cables very close to each other, you've got this one long connector all the way down. It's got the corresponding digital connection numbers next to it. So you've got 36 and 37 very close to each other on the board here, on the Arduino board, but on here you've got 36 and 37 clearly separated. So it makes it easier to screw these cables in place. And that's the only reason why I'm using that. Right, so I'm going to go ahead now, wire everything up and come back to you and show it all wired up. Okay, I've decided to split this video part 3 in half because it was getting to be about an hour and 40 minutes long, which is way too long. So what I've done is I'm going to end it now with part 3, which is the completion of the construction of the FCU, and in part 4 we'll do the programming using Mobiflight and FCU IPC. Here we are, this is the construction so far. As you can see, we've got all our buttons in, our rotary encoders are in, we've got an LCD screen here to display our heading and our altitude. I've got a couple of bits missing, but we haven't got to probe them in. I've got another screen that can go in here. I've also got one here for the Q&H on there. Couple of missing switches, the rotary switches for the EFIS, but pretty much it's all there, and the majority of it is functioning. There's the rear of it to show you back there. That's all the massive wiring and the Arduino shield here. So that's it for part 3 anyway, and in part 4 we'll go through the programming with Mobiflight and FCU IPC7. Okay, well I hope you enjoy the video. Please like and subscribe and hit that notification bell, and I'll see you on the next one. Thanks very much.